Good morning, afternoon, evening, whatever it is, geometers. This is Miss Backfish, and I'm here to talk to you about this, using trig functions to find missing sides of a right triangle. Just being a little more specific here, trig is short for trigonometry, and when we talk about trig functions, we're saying sine, cosine, and tangent. Okay, so this is not just identifying what the sine or cosine or tangent is, but using it to find missing sides of a right triangle. When we get to this, we've already defined what those ratios are. Okay, the definition of the sine ratio, the cosine ratio is the adjacent side over the hypotenuse. Tangent ratio is opposite over adjacent. Now, opposite from what? Adjacent from what? You always have to know what angle, sorry that's kind of a curved right triangle side, but you have to know specifically what angle. So you'll never see just sine by itself. And by the way, the word is sine. This is an abbreviation. So you'll never see just sine. It's always sine of something. Here, this is the Greek letter theta. It could just be an X instead, or it could be a capital A or something like that. The sine of my angle is equal to the opposite side over the hypotenuse. The cosine of my angle, and again, this is cosine. That's an abbreviation. And this is tangent. Okay. So for instance, if this were my angle, if that was theta, first thing I would do is look at the two sides of theta. This is just a method for making sure I know which side is which. One of those sides is always going to be the hypotenuse. So that's this one right here. The opposite across on the other side of the triangle. So that's what we're talking about when we talk about opposite, hypotenuse, adjacent. Hypotenuse is always hypotenuse. But opposite means opposite from my angle, or adjacent to my angle, okay? And that would change if we started looking at the triangle from this angle instead. Okay, so what we're doing here is we are actually finding missing side lengths, something like this. What we're not doing, and have already done at this point, we're just making a ratio, like because that's opposite over hypotenuse, 28 degrees. That's one where I would just put it in my calculator and get, oh, it was already on the screen. 0.469, so about 0.47. Okay, what we're doing here is specifically finding a missing side of the triangle. And to do that, first thing we're going to do is we're going to figure out which of these we want to use to set up an equation. The equation we're going to set up, we would also set up if we were trying to find a missing angle. If we're finding any missing part of a right triangle, we're going to first use one of these definitions to set up an equation we can solve. Okay, so the first thing I have to do in doing that is figure out which sides I'm working with. Here is my angle. This is the hypotenuse of this right triangle. This is the adjacent. So I need to work with the hypotenuse and the adjacent. And the trig function that does that is the cosine. So I'm going to set up this equation and fill in the things that I know. I know the angle, I know that adjacent, I could put an X, and I know the hypotenuse is 7. So I'll write an equation just like that. So cosine of my angle equals adjacent over hypotenuse. And then I solve. Now, to me, the easiest way to think about solving this is cross multiplying. Act like this is a fraction also. And then we solve proportions. We have a proportion now by cross multiplying. So I'm going to do 7 times cosine of 39 equals x times 1. Is x alone? I'm going to ask myself that question every time after I do a step. Is x alone? If x is alone, now it's time to pick up the calculator because now this tells me what to put in the calculator. If x was not alone here, I would keep going. This tells me x can be found by doing 7 times cosine of 39. I never pick up my calculator until x is alone. 5.44, I'm going to round to the nearest tenth. So x is about 5.4. And that's my answer. Also, notice it makes sense because that's a leg of the triangle, and the legs should always be smaller than the hypotenuse. All right, next up, we are finding this missing side in this right triangle. We know that this angle is 72 degrees. First thing I have to do is figure out which sides I'm working with. Here are the two sides of my angle. Here's the hypotenuse. I'm not working with that one this time. Here's the adjacent. This is the opposite. So the two sides I'm working with here are the opposite and the adjacent. So I have to look here and decide which one of these functions deals with the opposite and the adjacent. And it's tangent. So I'm going to take tangent and I'm going to set up an equation. I'm going to say, all right, tangent of my angle equals the opposite side over the adjacent. My equation is always exactly the same as the definition, just with things filled in. Now I'm going to put this over 1 and I'm going to start cross multiplying. So 20 times tan 72 is on one side, and x times 1 is on the other side. If it's always going to be x times 1, why am I cross multiplying? Because it's not always going to be. Okay, it's not always going to work out quite like this. So that's why I ask myself at this point, is x alone? If x is alone, it's time to pick up the calculator. And I can say 20 times tan 72. And get 61.55. So let's go with 61.6. So x is 61.6. Now, again, with the whole, does this make sense? Well, sides of triangle always correspond to the angle across from them in terms of how big they are. If this angle is 72, remember that the two acute angles of a right triangle have to add up to 90, because this is already 90, and 90 plus 90 is 180. So this is actually a very small angle. If a very small angle is across from 20, then this much larger angle needs to be across from a much larger number, and that is. So again, this does make sense. All right, next up. First step is figure out which sides of the triangle we're working with. Now let me point out, and we're just going to find x here, but sometimes you'll see it like this, where they really want you to find both sides. In that case, what you have to do is you have to just pick one to start with. You can't find them both at the same time. So let's say we decide we're going to find x first, and I'm just ignoring the y. And then later I could go back and find the y. If I already have two sides out of 3 of the triangle, I could even use Pythagorean theorem at that point. Well, let's just go ahead and find x. All right, so this is my angle. Two sides. This one's the hypotenuse, so this must be the adjacent. Here's the opposite. Remember, I'm not actually finding y. I don't care about this one at all. So I'm not going to use anything that has adjacent in it. I need to work with the opposite, and I need to work with the hypotenuse. So opposite and hypotenuse, that calls for the sine function. So I'm going to do a fresh piece of paper. Sine of 46, let's do it over here. Sine of 46 degrees equals the opposite over the hypotenuse. Put that over 1, and now I'm going to cross multiply. Now when I cross multiply here, I get x times sine of 46. And on the other side, I get 8 times 1. Is x by itself? Here's a case where no, it's not. X is not by itself, so it's not time to pick up the calculator. It's time to continue solving, which means trying to get x by itself. X is multiplied times this, so if I want to get rid of it, I have to divide by it. And notice that when you're manipulating it in an equation, sine of 46 is all one thing. It stays together. You don't separate the sine and the 46. Now x is alone, and it tells me what to put in the calculator. X equals 8 divided by sine of 46. So that's what goes in my calculator. Sometimes I'll have students ask me, how do you know whether you're going to multiply or divide? That's called solving the equation. Oh, I meant to do to the tenths. To the tenths, this would be 11.1. Okay, you solve the equation to know. You get x by itself, and then whatever's happening on the other side is what you do. Sometimes it's multiplication, sometimes it's division. Basically, the time it's division is going to be when your variable is on the denominator or in the denominator when you set it up. We're not going to find y here because I want to give you another one. All right, this is too similar. This is not what I want to do. This is very similar to the last one. So let's go ahead and do almost the same problem. But from this perspective, let's do it from that angle. Okay, so from that angle up here, I've got two sides. One of them is the hypotenuse. One of them is the adjacent. So that tells me I need to use the, sorry for the bell, cosine, because adjacent and hypotenuse are cosine. So cosine of 38 equals adjacent over hypotenuse. Now I'm going to cross multiply. I'll come over here. And I get z times cosine 38 equals 18 times 1. Sorry, I'm going off the page. 18 times 1 is 18. Now I need to divide both sides by cosine 38 to get z alone. And now z is alone. And again, I have not picked up the calculator until my variable is alone. Now, the opposite side tells me what to do. I'm going to do 18 divided by cosine 38, and 22.8 is what I get for z. Does that make sense in this concept, on this context? Yeah, because it's bigger than 18, and the hypotenuse needs to be the biggest side of the right triangle. I hope this has helped, and I will see if I can link some other videos I've made that are involving finding a missing side of a right triangle using sine, cosine, and tangent for you, and enjoy doing your right triangle trig. Bye-bye.